Dear children, it is a numerical problems in the chapter electricity. Now let us discuss the problems based on electric charges and current. That is, first let us discuss about the numerical problems based on electric charges and current. The first question. Calculate the number of electrons constituting 1 coulomb of charge. You know that charge on 1 electron equals. So let us take E equals what? Charge on 1 electron. So charge of 1 electron, that you know, that equals what? 1.682 10 to the power of minus 9 coulomb. That is the charge of 1 electron. Here let us consider 1 coulomb of charge is there. So total Q is total charge, that is nothing but Q. Q is nothing but total charge equals how many charges are there? 1 coulomb of charge is there. So you take that is 1C. Then how you look at the number of electrons? So you write that. So let us take N equals number of electrons. Number of electrons equals Q by E. Q by E, that is 1C by 1.6 into 10 to the power of minus 19C. So then that is equals to what? That is 1 by 1.6. 1 by 1.6 into, that becomes, if you take that 10 to the power of minus 19 to the numerator, it becomes 10 to the power of 19. Negative power becomes positive power, 10 to the power of 19. So then you will get, if you take, that is 10 to the power of 19. So to take the decimal, remove the decimal point, it becomes into 10 divided by. Now let us take, this is 10 to the power of 18 into 10 to the power of 2, that is 10 into 10 by 16 let us take. So you divide, that is 10 into 10 is 100, 100 by 16. 100 by 16, that equals 16 6 96, 4 is remaining. Then you take point, 16 2 32, 8, 16 5 80. So you'll get 6.25 into 10 to the power of 18. Here, how many electrons are there? 6.2 into 10 to the power of 18 electrons. That is the number of electrons in 1 coulomb of charge. That is N is equals to 6.25 into 10 to the power of 18 electrons are there. That is number of electrons in 1 C charge, 1 coulomb of charge. You take how much is 6.25 into 10 to the power of 18. Now let us take the second question. An electric bulb draws a current of 0.2 A when the voltage is voltage is 220 volts. Calculate the amount of electric charge flowing through it in 1 hour. Flowing through it in 1 hour. So, an electric bulb draws a current of 0.2 amperes when the voltage is 220 volts. Calculate the amount of electric charge flowing through it in 1 hour. So, here you write I. Solution, let us take solution. Here the current I equals 0.2A and time equals 1 hour. 1 hour means you convert it to seconds, that is 60 into 60 seconds, 3600 seconds. Then charge. What you have to find out? You have to find out Q equals question mark. And you know Q equals I into T. So what is the formula to find the charge? That is Q equals I into T. So you write Q equals I into T. I is 0.2 into 3600. And you know that 36 2s are 72. It becomes 7200, and here the decimal point must be after one digit. You will get 720C. 720C. So, the amount of electric charges flowing through it is 720 coulombs. And the answer here 720 coulombs. Then you take the third question. Show that 1 ampere is equivalent to a flow of 6.25 into 10 to the power of 18 elementary charges. Show that 1 ampere is 1 ampere is equivalent to a flow of 6.25 into 10 power 18 elementary charges. Or this question can be asked as the charge possessed by an electron is 1.6 into 10 power minus 19 coulomb. Find the number of electrons that will flow per second to constitute a current of 1 ampere. Or this question can be asked in this manner. The charge possessed by an electron is 1.6 into 10 power 19 C. Find the number of electrons that will flow per second to constitute a current of 1 ampere. constitute a current of 1 ampere. Here show that 1 ampere is equivalent to a flow of 6.25 into 10 to the power of 18 elementary charges, or the charge possessed by an electron is 1.6 into 10 power minus 19 C. Find the number of electrons that will flow per second to constitute a current of 1 ampere. Here, see here. Now, here the current is I is equals to 1 ampere and T is 1 second. Here it is per second. So that is elementary charges, that is per second, 1 second. And what you have to find out? Q. So you write Q equals I into T. That equals, you know that current is 1 and time is also 1, that equals 1C. And it is already shown charge on 1 electron equals charge on 1 electron equals, you know the charge of electron, that is 1.6 into 10 power minus 19 C, and number of electron equals, same question, if solved it, the first question it was there, number of electrons equals Q by charge of 1 electron E, that equals 1C by charge of 1 electron is 1.6 into 10 power minus 19, and it is already proved that equals 10 power 19 into 10 by 16. So you got it as 10 power 18 into 100 by 16, which is equals to, that is divided, if you divide 100 by 16 you will get 6.25 into 10 power 18. 10 power 18. So it is proved that 1 ampere is equal to a flow of 6.25 into 10 power 18 elementary charges. Then next let us take the third question. Ten power 20 electrons. 10 power 20 electrons, each having a charge of charge of 1.6 into 10 power minus 19 C pass from a point A towards another point P in 0.1 seconds. What is the current in amps and what is its direction? What is the current in ampere? What is its direction? What is its direction? So here you take number of electrons, n equals 10 power 20. So you write the solution, n equals 10 power 20 and E equals 1.6 into 10 power minus 19 C and T equals 0.1 S. Then here you take Q equals N into E, that is number of electrons and charge of each electron. So it is N is 10 power 20 into charge of each electron is 1.6 into 10 power minus 19. So it becomes, that 10 power 20, 10 power 19 becomes 10 power 20 minus 19 into 1.6 C, that equals 10 power 20 minus 19 is 10 into 1.6 C. So you will get 1.6 into 10 is 16 C. So you got Q is equals to 16 C. Then the relation current I equals what? Q by T. Q by T. Q equals I into T and I is equals to Q by T. Q you got 16C. And T, here T is 0.1 second. Here we have taken 0.1. Then it becomes, you remove the decimal point taking 0 in the numerator, that becomes 160 by 1 equals 160 amps. So here the current is 160 amps, and as the electron moves from point A to the point B, the current moves in the direction from B to A. You know that the conventional direction of the electric current is in the direction opposite to the flow of electrons. So as the electron flows from the point A to B, current flows from the point B to A. So right, the direction of current is the direction of current is from B to A, because you write because electrons moves from A to B. Next, let us take some more example on this. The question number 4th one you take. Question number 4. 1 billion means 10 power 9 electrons. 1 billion means 10 power 9 electrons pass from a point P towards another point Q, towards another point Q in 10 power minus 3 S. What is the current in ampere? What is the current in amps? What is its direction? What is its direction? Again here you take the N equals, that is 10 power 9, right? 10 power 9, and E you know is what? E equals 1.6 into 10 power minus 19c, and T it is given 10 power minus 3 seconds. 10 power minus 3 seconds. Now here you take the charge. Q equals N into E, that equals N is 10 power 9 into 1.6 into 10 power minus 19c, that equals, here you take 10 power 9, 10 power minus 19, that is 1.6 into 10 power 9 minus 19c, you will get 1.6 into 10 power minus 10c. Minus 10c. Then current. So you take current I equals Q by T. Q is 1.6 into 10 power minus 10c by T. T is 10 power minus 3 seconds. That equals, here you can take 1.6 into 10 power minus 10, and this, if you transfer this to the numerator, it becomes 10 power 3. 10 power 3. So it is 1.6 into 10 power minus 10 plus 3. You will get, that equals 1.6 into 10 power minus 7 amperes. And here the electrons moves from the direct point B to P to Q. So the electric current moves in the direction Q to P. So you write the electric current flows in the direction from Q to P. Electric current flows in the direction, flows from Q to P. Q to P. That is the answer. Next question let us take. That is the question number 5. Take that a charge of 150 Coulomb. A charge of 150 Coulomb flows through a wire in 1 minute. In 1 minute, find the electric current flowing through it. Find the electric current flowing through it. Here you write, here charge of 150 Coulomb is there, that is Q equals, right? Q equals 150C, and time equals 1 minute, that equals 60 seconds. Here what we have to find out? We have to find out the electric current flowing through it. You know that current I equals Q by T, that is charge by time. Q is 150 and T is 60. Then you will get 0 0 cancels. So 15 divided by 6, 6 2s are 12, 3 is remaining, and you can take 6 5s are 30. So you'll get 2.5 amperes. What is current? Current is 2.5 amperes. Next question let us take, that is the sixth question. You take sixth question. Calculate the charge passing through a lamp. Charge passing through a lamp in 2 minutes. In 2 minutes. In 2 minutes, if the current is 300 milliamps. If the current is 300 milliamps, here we have to find out. Now you take the current. Current is given in terms of milliamperes. So write I equals 300 mA, and you must convert this into ampere. You know that 1 milliampere equals 10 power minus 3A. So you must divide it by, so take, that is 300 into 10 power minus 3A, because 1 milliampere equals 10 power minus 3 ampere. So to convert this into ampere, you must multiply it by 10 power minus 3 as it is in milliampere. Then that becomes, so write it as it is, and you write time here. Time is given. Time equals what? 2 minutes. 2 minutes, that equals 2 into 60 seconds. Write the formula for Q. Q is equals to what? I into T. I into T. I is 300 into 10 power minus 3 into 2 into 60. Then you require 3 into 2 into 6. 3 2s are 6. 6 6 are 36. 1 2 3. 3 zeros. 1 2 3 into 10 power minus 3 C. Then it is 3 zeros, it means 36 into 10 power 3 into 10 power minus 3 C. So here it becomes 36 into 10 power 3 minus 3. So you will get 36 into 10 power 0 C, that equals 36 C. Next let us take the seventh question. A conductor carries a current of 0.4 amps. Find the amount of charge. Find the amount of charge that will pass through the cross section of the conductor in 1.5 minute. 1.5 minute. How many electrons will flow in this time interval given charge on an electron that you know that equals 1.6 into 10 power minus 19 C. Here what is given? Conductor carries a current of 0.4 amps. Find the amount of charge that will pass through the cross section of the conductor in 1.5 minute. How many electrons will flow in this time interval? Given charge on an electron, one electron is 1.6 into 10 power minus 9. Here current is given, that is I equals 0.4 amps and time is given t equals 1.5 minutes, that equals you write 1.5 into 60 seconds. Then what you have to find out? We have to find the amount of charge, that is Q equals question mark. You have to find Q equals a question mark and also N equals question mark. How many electrons is there? So you write N equals question mark, number of electrons. So then you write the formula, the relation between Q, I and T is Q is equals to I into T. Q is equals to I into T. I is 0.4 into T, 1.5 into 60. So it becomes 4 into 15 into 6 you take, that is 15 4s are 60. So you take, if you take 60 into 60 is 6 6 are 36 0. So you will get 3600 and decimal point 12. So it becomes 36.00. Now that is nothing but Q equals 36C. Q equals 36C. Then next what you have to find out? N. And how will you get N? Here N equals Q by E. N equals Q by E. E is given charge of a electron, that is Q. Q is 36 by E. E is equals to what? 1.6 into 10 power minus 16. 10 power minus 16, that is equals to, you take 36 by 16 into 10 power 1.6 into 10 power minus 19, that equals 36 by 16 into 10 power 20 it becomes. Here 1.6 into 10 power minus 90, that equals 16 into 10 power minus 20. You must write 10 power minus 20. Here it becomes 1.6 is equals to what? 16 into 10 power minus 1. Or it is, you know that 1.6 means 16 by 10, that is equals to 16 into 10 power minus 1. Here 1 minus 1 power is to be added to this minus 19, that becomes 10 power minus 20. Then you divide 36 by 16. So write 36 divided by 16, 16 2s are 32, 6 minus 2 is 4. Point to write 16 2s are 32, 8. So it is 5s are 2.25. Becomes 2.25 into 10 power If you shift this minus 20 to the LHS, it becomes 20. That is electrons. So number of electrons is 2.25 into 10 power 20 electrons. Now let us solve the problems based on work done W, potential difference V and charge Q. Now let us write the first question. Find the amount of work done in. Find the amount of work done in moving a charge of charge of 5 Coulomb, charge of 5 millicoulomb, 5 mc across 2 points having a potential difference across 2 points having a potential difference of 100 V. Here what are given? Charge is given and potential difference is given. Then what we have to find out? We have to find the amount of work done. And you write Q equals 5 millicoulomb, that is equals to 5 into 10 power minus 3 coulomb. And potential difference is given, V equals 100 volts. And what you have to find out? We have to find W, work done in bringing the charge of 5 millicoulomb across 2 points having potential difference of 100 volts. Then what is the relation among these three? W, Q and V. W is equals to Q into V. W is equals to Q into V. Then Q is 5 into 10 power minus 3 into 100. So that you will get 5 into 10 power minus 3. 100 means 10 power 2. That equals 5 into 10 power minus 3 plus 2. Then you will get 5 into 10 power minus 1. That is nothing but, that is W is equals to 5 by 10 power 1, 5 by 10, that equals 0.5 J. How much work is done here? 0.5 joules of work is done. That is the answer for this question. Find the amount of work done, that is 0.5 joules of work is done here. Then next let us take the second question. How much work is done in? How much work is done in moving a charge of 3 coulombs from a point 38 volt to a point 48 volt. Here the potential difference is to be find out. So you write, what is that? Q. Here Q is 3. Q equals 3C. And potential difference V equals 48 minus 38, that equals 10 volts. Then you write the formula. What you have to find out? Work done. Then the right formula is W is equals to Q into V, that is Q is 3, V is 10, that equals 30 joules of work is done here. 30 joules of work is done. Then the next question, third question you write. Third question, how much energy is given to each coulomb of charge passing through a 6-volt battery? How much energy is given to each coulomb of charge, passing through a 6-volt battery? Volt battery. Energy given by battery we have to find out. That is nothing but work done. Work done is equals to energy given. So write here Q is there. Q is equals to 1C, and potential difference V is equals to 6 volt, and we have to find out work done, that is nothing but E. E is nothing but equals to work done, that is equals to question mark, and you write E is nothing but W. E is equals to, what is that? Q into V. Q is 1 into 6, that equals 6 joules. So 6 joules of energy is to be given to each coulomb of charge passing through a 6-volt battery. That is the. Now the question 4. 100 joules of work is done in moving a charge of 5 coulomb from one terminal of battery to another. What is the potential difference of the battery? So here work done is given. Write that W is equals to 100 joules of work, and charge is given. So write Q equals 5C. And what we have to find out? We have to find the potential difference V. Write V equals question mark. You know the relation among W, Q and V. You know that W is equals to Q into V. That is Q into V is equals to W. V equals what? W by Q. That equals W is 100 and Q is 5. 5 ones are 5 20s are. So V equals 20 volts. V equals 20 volts. Now the fifth question. Calculate the potential difference between the two terminals of battery if 100 joule of work is required to transfer 20 coulomb of charge from one terminal of the battery to the other. So here work done is given, that is W is equals to 100 joules, and charge Q equals 20C. Then what you have to find out? We have to find out V, potential difference. Then you know V into Q equals, or Q into V equals W. Q into V equals W. V equals W by Q, that equals W is 100 and 20. So V equals, that is 100 joule by C, that equals what? 21s are 25s are 5 volts. So what is the potential difference? The potential difference is 5 volts. Now the main C, that is the numerical problems based on Ohm's law. So you know, according to Ohm's law, V is equals to Ri. So let us take the first question on the Ohm's law. What would be the resistance of a conductor if the current flowing through it is current flowing through it is 0.35 amps when the potential difference across it is potential difference across it is 1.4 V. Here, what would be the resistance of a conductor if the current flowing through it is 0.3 A when the potential difference across it is 1.4 V. So you write V equals potential difference, that is 1.4 V, and the current is given, that is I is equals to 0.35 A. And what we have to find out? We have to find out the resistance of a conductor, that is R equals question mark. According to Ohm's law, resistance R equals V by I. You know that V equals R into I and R is equals to V by I. Then you write V is 1.4 and I is 0.35. That equals, you take 0 and remove the decimal point, that becomes 140 by 35. And you know that 7 5s are 35, 7 20s are 5 1s are 5 4s are. So you will get 4 ohms. Then what is the resistance of a conductor? Resistance of a conductor is 4 ohms. That is R equals 4 ohms. Now the second question. Calculate the resistance of a conductor when the current flowing through it is flowing through it is 200 milliampere and the potential difference is potential difference is 0.8 V. Here what are given? Current is given, potential difference is given, and what you have to find out? We have to find the resistance of a conductor. So you take current is 200 milliampere. You know that is equals to what? 200 into 10 power minus 3 amperes, and potential difference V is given, that is 0.8 V. Then what you have to find out? We have to find the resistance. Calculate the resistance. R equals question mark. Then you write the formula for R, that is R equals, according to Ohm's law, R is equals to V by I, that equals V is 0.8 and I is 200 into 10 power minus 3. Then it is, if you take 0.8, if you take this above, that becomes 10 power 3 by 200. That is nothing but 0.8 into 1000 by 200. And 0 cancels. 2 1s are 2 5s are. So you got here 0.8 into 5, that equals 4.0. 8 5s are 40. 4.0. So you got R equals 4 ohms. What is R? R is 4 ohms. Next, let us take the third question. The potential difference across the potential difference across the terminals of a cell is 1.5 volts. It is connected across a potential across a resistance of 30 ohms. Calculate the current flowing through the circuit. Calculate the current flowing through the circuit. So here the potential difference across the terminals of a cell is 1.5 volt. It is connected across a resistance of 30 ohm. Calculate the current flowing through the circuit. So you take the potential difference is given. Note down V is equals to 1.5 V and R equals 30 ohms. What you have to find out? Find I. I equals question mark. And you know the formula for I. Here you know that V equals Ri. That is Ri equals V. Ri equals V. Here we have to find out I means I equals what? V by R. I equals V by R. Then I is equals to, you write 1.5 and by 30. 1.5 by 30. Then you take 15 by 300. If you want to remove this decimal point, you must take extra 0 in the opposite, that is in the denominator. Then it becomes 15 ones are 15 20s, 1 by 20 amps. So you got the current I equals 1 by 20 amperes of current. Next, let us take the question. Fourth question. An electric heater draws a current of 10 amps when connected to when connected to a 200 V supply, 200 volt supply, what will be the heater draw when it is connected to, what will be the heater draw when it is connected to, when it is connected to 220 V supply. Here an electric heater draws a current of 10 amps when connected to a 200 volt supply. What will be the heater draw when it is connected to 220 V supply? Here we have to find out the resistance of a conductor, and after that by using that resistance then we will get the current by using this 220 volt. So here R is constant for both volt and current. We take in the first case I equals 10 amps and V equals 200 V and R equals question mark. Then you write the formula for R. R equals what? V by I, that equals V is 200 volts and by I is 10 amps. So you will get 20 ohms. Resistance is 20 ohms. And in the second case, the supply is changed here to 20 volt supply. And what we have to find out? What will be the heater draw and the current drawn by the heater when it is connected to 220 volt supply. So in the second case you take, what is there? V is 220 volts and R remains same, that is 20 ohm. And what we have to find out? I we have to find out amount of current drawn by the heater. So you write I equals, again it is V by R. R equals V by I. Here R equals V by I and I equals V by R. So use the relation I equals V by R, that is V is 220 and R is 20. Then cancel this, that equals 2 ones are 2 11s are 11 amps of current will be drawn by the heater if it is connected to 220 volt supply. Now let us take the fifth question. When a 12 volt battery is, when a 12 volt battery is connected across an unknown resistor, there is a current of 2.5 milliamps in the circuit. Find the value of the resistance of the resistor. Find the value of the resistance of the resistor. Here 12 volt battery is connected across an unknown resistor. There is a current of 2.5 milliamps in the circuit. Find the value of the resistance of a resistor. So here let us write the volts. Voltage is 12 volts and a current is equals to 2.5 milliamps, that equals 2.5 into 10 power minus 3 amps. Then what you have to find out? We have to find the resistance of a resistor. Resistance of a resistor. So let us write the formula for the resistance. R is equals to V by I, that equals V is 12 volts and I is this much, 2.5 into 10 power minus 3. 2.5 into 10 power minus 3, that equals, that becomes 12 into 10 power 3 by 2.5. So you will get that 12 means you put 10 here and 1000, that by 25, because to remove the decimal point we have to take one more zeros in the numerator. So you know that 25 ones are 25, 4s are 100, 40 is 1000. Then it becomes 12 4s are 48. 12 4s are 48 and extra 2 zeros you put. That is 4800 ohms. 4800 ohms, that is the resistance of a resistor. What is the resistance of a resistor? Resistance of a resistor is 4800 ohms. Here we completed some examples on the Ohm's law.